Hey Algebra 3, this is your lesson on section 7.4. We're going to be adding, subtracting, and multiplying radicals. Before we get into adding and subtracting and multiplying radicals, what we need to understand is something called like radicals. Like radicals are radicals having the same radicands, and I'll explain what that means too. They are added the same way like terms are added to. Okay, so let's look at some like radicals. What we have here is having the same radicands means this right here is whenever we have the same value on the inside of our radical and then the same index on the outside of our radical, then these are considered right here like radicals. And then how we add them together is we simply add together the numbers that are before the radicals. So you add together 5 and 4. So for this example, our solution to this addition problem would be 9 fourth root of 2. So just like treating this as x, like 5x plus 4x, you get 9x. Okay? Same goes here. It's understood that this is 2 on the outside here. Same here. So they all have the same index. And looking on the inside of our radical, they're all the same values on the inside. So these are considered like radicals. So your solution to this would end up being, let's see, whatever 3 plus 10 minus 5 is. So let's see, that's 5 plus 3, so 8. Square root of x, y, z squared. Okay, and then same thing down here. If we do not have like numbers, if we do not have the same numbers on the inside of our radicals, then this right here is as far as we can simplify. We can't add anything together at this point. Okay, so let's look at some more examples. All right, so here are the steps to adding or subtracting radicals. First, we need to use the skills that we have learned in the previous couple sections. We need to simplify each radical expression. And then second, combine the like radicals if there are any. So in this problem right here, first step is simplify these radicals. Okay, and let's see. I'm going to go ahead and write this out step by step. On the inside of this radical 250, we can split that into these two factors, 25 and 10. And then the same thing goes with the next one, the square root or 5 square root of 160 can be split into 16 times 10. Okay, now I'm going to take the square root of 25 for that one and the square root of 16 for that one. We get 3 times 5, because the square root of 25 is 5, times the square root of 10. And then 5 times the square root of 4, because the square root of 16 is 4, times the square root of 10. Multiply these values, you get 15 square root 10 plus 20 square root 10. And then add together, since these are like radicals right here and here, we add together the 15 and 20 to get our final answer of 35 square root 10. And that's it. All right, another example on adding and subtracting radicals is one like this. Let's go ahead and do our first step, simplify each radical expression. So let's simplify this and this on the inside of our radicals. And we're going to get, let's see, fourth root of 48 can be split into 16 and 3, and x to the 5th right here. I'm going to go ahead and split that up into x to the 4th and x. And then subtract that from x, 4th root of, let's see, 3, again, x to the 4th times x, and then y to the 4th. Now let's take everything out of the radicals that we can, taking the 4th root of them. So 3 times y times, we can take the 4th root of 16, that's going to be 2. And then take the 4th root of x to the 4th, that's going to give us x. Then everything else stays on the inside of our radical. So 3x. Let's write that a little shorter. There we go. And then on this one, we can take x to the 4th. We take the 4th root of that. That's going to give us x. And then we can take the 4th root of x, or y to the 4th, which gives us y. And we're left with 3x on the inside of our radical. Don't forget that 4th root. All right, now let's combine everything we can. This 3 times y times 2 times x gives us 6xy. 4th root of 3x. And then this gives us x squared y. And then 4th root of 3x. Now these right here are not going to be like radicals. We cannot add these two together or subtract these two because of what's on the outside of our radical, what it's being multiplied by. This has a 6xy in front, and this has an x squared y. Now, if this was just a single x value right here, xy, then we could go ahead and combine these as like terms and like radicals. But since we have x here and x squared, these are not like terms anymore. So this is as far as we can simplify at this point. Now, for a little caution here, the product rule does not apply to addition or subtraction. So we've had this product rule here that we've discussed in class before, and we can say square root of a times the square root of b is the same thing as the square root of a times b, and put a and b together. But this right here, the square root of a plus the square root of b does not mean the same thing as the square root of a plus b. You can't do that because remember, when we add radicals together, they must be like radicals. And then whenever we put the like radicals together, we don't even add the terms that are on the inside of our radical. All right, so here we go on multiplying radicals. It's not much different than what we've been doing before in multiplication of any values. But here we have 3 times the square root of 5 minus the square root of x. Since these are not like radicals, we don't put them together. But we can go ahead and distribute this 3 and just come up with 3 square root 5 minus 3 times the square root of x. And at this point, we are done with that problem. This problem right here, we use our foiling method to help us in multiplying all these out. So let's go ahead and do that. Whoops, where'd it go? There it is. Okay, it keeps disappearing. There. Okay, so multiply first terms together to get 48. And then these two terms get plus 6 square root of 5. And then oops, that's supposed to be a minus sign. Minus 8 square root of 2. And then minus these last two terms we put together is going to give us square root of 5 times the square root of 2, which is the square root of 10. At this point, after multiplying everything out, what we do is we look at everything to see if we can combine anything that may have like radicals, and there aren't any like radicals in this one. So this right here is our final solution. Okay, on this one, we're going to go ahead and FOIL just like we did the last one, but then I'm going to show you a shortcut to problems such as this one. So first terms, square root of 3 times the square root of 3 gets us square root of 9, which is 3. And these two give us minus 6 square root 3. And these two, 6 square root 3. And last, minus 36. Okay, we can combine these two together since they are like radicals and they actually cancel each other out. And this whole thing will give us negative 33. And that is our solution. Okay, on this thing where how I can show you a shortcut. Hold on for just a second. Here's a shortcut to this. If we have radicals that say the same exact thing inside both of our parentheses, except there's been a sign change in the middle, one's plus, one's minus, what these are called are conjugates. And whenever we have conjugates that we're multiplying together, the only thing that we have to multiply together are the first two terms and then the last two terms. We can skip the inner and the outer terms on the foiling method. So when we do that, we get, let's do that, square root of 3 times the square root of 3, that's 3. And then square root of 6 times the negative square root of 6 is 36, which gives us negative 33. And ta-da, there we are done. So remember that. It's just a little shortcut on multiplying conjugates together. And that's all I have for you guys, and I hope you understand how to do all this, and I will help you out with all your problems that you have during class tomorrow or whenever I see you next. So goodbye, everybody.